We're going to look at a problem now where we've obtained 3 compass bearings. In this example we're going to assume that we've obtained 3 compass bearings of 3 lights. Light A, light B and light C. So on the drawing this is the coast along here and these are 3 lights. We're somewhere in this vicinity here and we've obtained 3 compass bearings. Now we can't just simply plot those bearings because they're compass, they're not true. So if we plotted the compass bearings we'd be incorrect. We're not told the compass error, so we can't convert these compass to true. We're not told the ship's head, so we can't calculate deviation, variation and compass error. So how do we find our position having obtained 3 compass bearings? Okay, well let's have a look how we do this. So just drawing this roughly, light A we're told was 295 degrees compass, so that's north, so 295 degrees compass, so the bearing is approximately there, 295. Light B we're told is 025 degrees compass, so let's just, so that's approximately 025, and light C is 065. So we've a bearing of 295, 025 and 065. Now they're all compass bearings. What is true and what is factual in this instance are these 2 angles. It doesn't matter what error we have in the compass, the angle between 295 and 025 is a true value, and the angle between 025 and 065 is also a true value. So if we were to calculate those, 295 to 025, that's 295 to 360, 65 plus 25. This angle here is going to be 90 degrees, and from 025 to 065 is going to be 40 degrees. So we know as a fact these 2 angles of 90 degrees and 40 degrees. And it's by using these 2 angles that we look to solve this problem. So with the same drawing here, I've just done a small sketch there, 295, 025, 065, and 295 to 025 gave us a 90 degrees, 025 to 065 gave us 40 degrees. Now the way we solve this problem, we subtract these angles, these 2 angles here, 90 degrees and 40, we subtract each of them from 90 degrees. So A to B, 90 degrees minus 90 degrees gives us 0, and B to C, which was the 40 degrees, 90 degrees minus 40 gives us 50 degrees. Okay, so the first thing we do, we draw a baseline between A and B. So, and we draw a baseline between lights B and C. So on the chart you join up A and B and C. And we get a protractor and we have to put the angles of 0 degrees and 50 degrees on our chart. We place our protractor on B and then on A, or A and B, it doesn't matter which way you do it. At 0 degrees, we can see at 0 degrees that side, 0 degrees that side, so effectively we're on this line. We're taking it on this line because it's 0 degrees. So what we need to do is calculate halfway between A and B. Between B and C we have 40 degrees. So what we need to do here is measure an angle of 40 degrees, 90 degrees minus 40 is 50 degrees. So we have to measure an angle of 50 degrees from off the baseline at C, and also we go to B and measure an angle of 50 degrees. So the angle here is going to be 50 degrees, the angle there is going to be 50 degrees, and we have this intersection here. Of course, this line here, because it was 0 degrees, we simply find the middle point along that line. Any angle that's less than 90 degrees is plotted towards the vessel with the protractor. Any angle of exactly 90 degrees is on the line, and any angle that exceeds 90 degrees is on the land side, away from the vessel. So once we've put these positions on using our protractor, we then place the protractor where the two lines intersect, put them on lights B and C, and then we draw a circle. Now the circle has to go through B and C. So that's our first circle. We then take the midpoint of the line between A and B. So that's the line between A and B, and again we draw a circle. And where those two circles intersect here will be the vessel's position. Where the two circles intersect will be the vessel's position. There's also a third angle which is a true value. And that, of course, is the angle between 295 and 065. In other words, the angle between light A, and light C. And between light A and light C is 90 plus 40 is actually 130 degrees. So between A and C, if we subtract 130 degrees from 90, we get minus 40 degrees. Because it's a minus value, we plot that away from the vessel. So let's join A and C. And once we've joined A and C, we need to plot 40 degrees. So again, we put our protractor on C and plot an angle of 40 degrees. We do the same at position A, place our protractor on the baseline between A and C, measure 40 degrees. And we draw a line up at 40 degrees. So the angle here and here are both now 40 degrees. Where the two lines intersect, place our compass. The circle should cut both C and A, which it does, and as we can see, it passes through our fix. So that's a check to see if you've got the correct position. We have plotted the vessel's position, having been given initially compass bearings. If we, from this fix, if we then measure these bearings A, B and C and take them off the compass rows on the chart, they will in fact be true bearings. So if we compare those true bearings to the compass bearings, we should be able to calculate the compass error for the vessel. And with that compass error, if we've been given the variation, or we know the variation off the chart, we can then calculate the deviation for the vessel. Because if we have compass error and variation, we can calculate deviation. And you should find that the compass error for each A, B and C, 295 compass, 025 compass, 065 compass, the compass error, in other words the difference between compass and true for each one, should be the same. And that's how you solve the problem when you're given 3 compass bearings.